of these things you're expected to know. They're very common. They're used a lot. You should know the formula. Others of them, it's like you would probably look this up if you ever had to use it again, and those formulas I'll tell you can use them on the test, like a list of them. I'll put them on the board. Okay? But there are some things we should just know. Okay? So, for example, you guys think of the cotangent often as x over y, right? But in the unit circle, what else is equivalent to x? Cosine. Okay, so another way to think of the cotangent is the cosine over the sine. Okay? So what would the tangent be like? Sine over cosine. So why is this important? This is important in these proving types of things to be able to substitute and use them interchangeably. Sometimes it's more helpful to rewrite this in terms of sine and cosines because there are other things in terms of sine and cosines, and then I can put them together and figure some stuff out. Sometimes I see this and there's other tangents in the problem. It's important I can recognize that it's a tangent, rewrite it as tangent, and then combine stuff together to make it simpler. Okay? So secant, yeah, good, is 1 over the cosine, whereas cosecant is 1 over the sine. I don't know why cotangent's on there twice. Sorry. I must just really like it. Okay. So when we're doing these things, a lot of the properties you guys are going to use, you're going to use factoring. You're going to use all these skills that you've built in Algebra 1 and Algebra 2, but you're going to apply them to things that are trig looking, okay? So for example, here, we've done problems like this before. To simplify a problem where we have a number and then this rational expression, we make a common denominator and we combine them together into one fraction. So right now, this has a denominator of 1, but the common denominator would be x. So I'm going to multiply numerator and denominator of this fraction by x. Okay? And so the simplest form of this would be to say x plus 3 over x. Okay, that's that fraction. Now, I did not solve. Okay, I did not prove. I simplified. But notice, could I have taken this and multiplied everything by x? Is that okay? Am I changing the value if I multiply this by x? Pretend x is a number for a minute, and somebody gave you this. If you're supposed to simplify that and add it together, is it okay for you to just go like this? Are you going to get the same answer when you finish this problem that you would have gotten from the original problem? No. Okay? Not okay to just multiply everything by x. Okay? When would it have been okay? Now can I multiply everything by 2? And this doesn't make sense, but okay. But when the x's go in there, it seems a little more, okay, now I can multiply everything by x because they gave me an equation to solve, and I'm really multiplying this side and this side by the same thing and keeping equivalency. So these are going to be really important to you. You cannot treat these like you're solving. If I'm asking you to prove something, even though it looks like an equation, you can't go, I'm going to multiply both sides by 2. I'm asking you to prove to me that they're equal. If you go multiply both sides by 2, you're pretending like they're already equal and you're allowed to multiply both sides by the same thing. That's not okay. All right? So anything that's proving or showing that something is equivalent, you can't use your solving strategies on that. Because solving things were used in something you for sure already knew was equal, and then because they were equal, you could do these things as long as you did them on both sides. Okay? All right, so we should know what this turns out to be. Jordan, sorry. Good, it turns out to be 1. Okay? So if you guys wanted to see something a little bit more similar to what you just did, but a little bit different, so you guys saw the unit circle. We always thought of this as the radius, and then to get to that point, this would be the x and this would be the y. Because that's a right triangle, I know that x squared plus y squared equals r squared. Fair enough with everybody in each circle that I draw like that. If the sine is x over r, no, I'm totally not sticking it. Okay. The sine is y over r, and I'm squaring it. And the cosine is x over r, and I'm squaring it, then what I'm getting here is y squared plus x squared over r squared. But what is x squared plus y squared equal to? r squared. So this is really r squared over r squared, which is really just 1. So back to the identity that you proved in the investigation last night too. So this is a huge identity. This is not one I'm going to give you. This is one like we have to know and be familiar with. Sine squared theta plus cosine squared theta is equal to 1. Okay? So these are called, like I mentioned before, the Pythagorean identities. Okay? So the first one is sine squared theta plus cosine squared theta equals 1. Okay. So when we see sine squared plus cosine squared, that's going to be a huge red flag to us to plug in 1 instead, okay? A lot of time. But you might see it some other ways, okay? So sometimes you might see something like sine squared theta is equal to what? Ashley?
1 minus cosine squared theta.
Yeah. So why would this be useful to me? Why would I want to know it? Well, if I have a huge expression and has a sine squared in it, but the rest of the stuff is all based on cosine, it'd probably be better for me to rewrite the sign in terms of cosine. Maybe there's some things I can simplify and combine together. Okay? And just like that, cosine squared theta could be rewritten as 1 minus sine squared theta. Okay? Is this all right with everybody? All right, I'm going to actually take you to example 1 first and then come back to this because I want you to see. All right, so here's example 1. Show that this is true. So here's the thing. I'm going to try to do my work on one side. You're technically allowed to work on both sides, but here's what I found. When I give you guys that freedom, you guys do things you shouldn't do. Like I cannot go right now and multiply both sides by 2. One, that wouldn't help me at all, but normally you guys would look at this and say, yes, you can multiply both sides by 2 because it is an equation, right? But is this really an equation yet? Is it really two things that are equal to each other? I don't know, because what am I supposed to be doing right now? Showing that they are equal to each other. So can I start doing things on both sides because I know they're equal? No, that's totally productive to what I'm being asked to do. I'm assuming they're equal to do this to show that they're equal. That doesn't work, okay? So what we would do is we would start plugging some stuff in. So for example, I'm going to start on the left side. Why would I ever want to start there? Well, for me personally, I see cotangent on the left side, and I know something about how I could rewrite cotangent, okay? I could rewrite cotangent as cosine over sine, right, based on the stuff we did earlier. So I would think of this as cosine over sine, okay? Then you're looking at it going, that was dumb, right? That doesn't look like cosecant on the other side, whatever. But this is something plus a fraction if I want to combine these two things together. And then you're thinking, why would she want to combine them together? Well, look at the other side. How many terms are on the other side of this equation? 1. I would like this to turn into 1 term. So my goal is I'm trying to take steps towards getting some stuff that matches what's over there. So to turn this into 1 term, I need a common denominator. So I'm going to rewrite my 1 as what? Penny? Good. Good. So sine squared theta over sine squared theta. Okay? Now I can combine these fractions into 1 fraction because they have the common denominator. The denominator of them will be sine squared theta. The numerator will be sine squared theta plus cosine squared theta. Okay? Am I any closer or any better? Good. The top equals 1. We have an identity that says sine squared plus cosine squared is equal to 1. Okay? So I can substitute sine squared plus cosine squared is 1. So I have 1 over sine squared of theta. What is 1 over the sine of theta? Cosecant of theta, and this just happens to be its square. So I now have the cosecant squared of theta. I am done. I made it equal to the other side. Okay? Okay, so what we just did technically is we just proved one of the other Pythagorean identities. So the reason there was 3 boxes on the previous page is there's actually 3 identities that are based on this idea of Pythagoras theorem. Okay? So this is the first one. The second one is what we just proved. Okay, so we just proved 1 plus the cotangent squared theta equals the cosecant squared theta. And there's another one, tangent squared theta plus 1 equals secant squared theta. And you could see how the third one could easily be proven the same way that we just proved the last one. Okay? So we kind of get the feel for what we're doing, and we're basically going to have a whole catalog of these things that we eventually discover that are very useful in substituting to be able to try and prove these different things. Okay? All right. So our job here is to verify these identities. Get through that. All right, so let's look at part A. So when you're making a verifying, showing that they're equal, you cannot assume they are equal. You cannot divide both sides by cosine or something like that. That's not going to work here. You need to kind of pick a side and say, I am going to work on simplifying and substituting on this side because I see at least one thing I could maybe start with. Hopefully that will lead me to get closer to what I see on the other side. Okay? So which side do you feel like you could at least substitute or simplify something? Jordan? The left side. Okay, I agree with her. The left side has more stuff. I always like to start usually where there's more things because there's stuff for me to do to them. Okay? So the first thing that stands out to me there is the cotangent because I can rewrite it. Right? So how can I rewrite the cotangent? Cosine over sine. Good. So what's going to happen when we multiply sine of theta times cosine theta over sine theta? The sine thetas are going to cancel out. I'll be left with cosine theta, and that's all that I want. Okay? Yeah, part B is the same. I don't know why this kept happening on this note guide. Apparently I really liked certain things. So you can cross out part B. Any questions on part A? Huh? All right, so part C. Where do you guys want to start? Somebody besides Jordan. She's on it. Got it. Lauren. Okay, so we're going to start on the left. What does somebody see on the left that we could work to replace? Yeah. Okay, so I can't do that. All right, so that's what we were talking about earlier. But everyone's going to feel that way. That's the hardest part about this. We want to, but when you multiply both sides of an equation by something, you're saying because these two things are equal, I know that I can do this to both sides and they're still equal. But I'm asking you to prove that they're equal. So you're not allowed to multiply both sides by the same thing when you're trying to verify or show that the equation is true. Because that's something you do when you know that they're true. Samantha? Good. So 1 minus cosine squared theta is going to be replaced with sine squared theta. How does sine squared theta over sine theta simplify? One factor of sine cancels, right? Which means there's one left in the numerator, okay? So it's just like x squared over x. Okay? And I'm done. So remember, when you're verifying or showing that a relationship is true, you can't multiply both sides. What you're going to do is pick a side and substitute and simplify all on that same side so you can manipulate it to make it look like the other side, okay? You have to become a master manipulator. Okay? Jordan already is. Yeah, Ken. No. So again, you can't do anything from one side to another because when you're doing that, when you guys solve equations, someone is telling you this is equal to this. And you are saying, oh, since this is equal to this, they'll stay equal if I subtract 2 from this and also subtract 2 from this. But I'm asking you to prove they are equal. If you do that, you're trying to prove something equal by doing things you can only do when they are equal. So it's kind of contradictory. Okay? Yes, one. What's that? From the identity. So if we go back from this identity, okay, it can be manipulated so that sine squared is equal to 1 minus cosine squared. Okay. Oops, I skipped one. All right, part D. New person. What side do you want to start on? Andrew. The left. All right. Okay, so Andrew has chosen the left for us. Somebody tell me something that I can do over there on the left side. Van. Okay, and we write it as 1 over cosine. So when I do that, so I have sine squared times 1 over cosine. All right, so I'm here, and I'm going to go ahead and take this extra step of just saying that means that this is this fraction. Jordan? Okay. Okay, so I can't. So tricky. I can only do it when they're squared. Yeah. Oh, I was just kidding. It's because I forgot to write squared. All right, we're doing it. Yes. You are totally right. I apologize. All right. What has to happen on the left for it ever to become what's on the right? Yeah, secant is basically 1 over cosine. So basically to make that happen, this stuff eventually has to be combined together as one thing. We can't have this plus this, right? Okay. So we need a common denominator to combine them into one fraction. So that's my advice. When you feel stuck and you're like, I don't see something new, but you have more stuff over there than it's on the other side, get the stuff together as one thing. Okay? So to make this have a common denominator where right now it's technically 1, I would multiply top and bottom of this by cosine. So this would look like cosine squared theta over cosine theta. All right. So where am I at now? Savannah? Uh-huh.
Put cosine theta as the denominator and add that fraction that you have on the second step.
Cosine theta. You could, if you make this cosine squared over cosine, you could do that in that order instead. That's fine. Okay. More? Good. So the denominator here is cosine. And when I add all the numerator together, I have 1 minus cosine squared plus cosine squared. So the cosine squareds cancel out, and I'm just left with 1. So like she said, that is the secant. Okay. Told you, kind of like puzzles, right? Okay, so the other, let me make sure I give you enough for your homework. Yeah. So the last thing you're going to be asked to do is simplify. The hardest part here is to know when to stop because you're trying to put things together. So this is a lot like the example that we did at the beginning that was 1 plus 3 over x, and it said simplify, and we said, oh, we should combine it all into one fraction. Okay? So basically, you want to get it combined into one fraction, okay, most of the time. If it can then be put into one term, you want to make it one term. So this is already one fraction. But the question is there a way to write that is simpler, meaning using all the same trig thing and as condensed as possible, okay? So I can't tell right now if it's something else or not. Any ideas on what you guys want to try? Jordan? Okay, so the numerator, the 1 plus cotangent squared, if we go back to those identities, okay, it was 1 plus cotangent squared is the same as cosecant. Okay, so she's saying let's make that a cosecant. So that definitely looks like a step in the right direction. It looks pretty simple. I don't feel like anything can cancel, but remember, these guys are almost in discuss, okay? Yeah, that's good.
So then you do 1 over sine squared
Uh-huh.
on the top, square
I'm not coming to work on Monday because Jordan's just going to teach you guys. I hope you guys are good with that. That's as simple as I can get. It's one trig function in its simplest form, one term, okay? So again, the goal is to condense it down to as simple as possible, and simple means anything that was canceled could be canceled. Anything that was rewritten as one term instead of two is rewritten as one term, okay? Is this all right? So your homework tonight is going to be simplifying and like verifying that things are true. Based on using your tools, so far you have three main tools, those three identities that we wrote in the box. Does that make sense to everybody? Okay, so the homework's listed on Canvas. Assignment sheet, note guide will be up there soon. The module's all set up. There's just not stuff inserted inside any of those things. But that means the assignment's already listed. It already has the due date on there. You have these notes to help you, but you can print out the rest this weekend. This was the first 2 pages in what I just gave you. So if you're printing it yourself, you can skip the first 2 pages. Okay?